Hi students, welcome back to my channel Innovative Challenge. This is Anil Kumar Behera, your physics lecturer. In previous class, we have already discussed about axial line and equatorial line uh, of magnetic field. So how can we find the magnetic field due to axial line and equatorial line of magnetic dipole? But now today we will discuss about magnetic field due to dipole at any point. It means any point means that the point which is present neither axial line nor equatorial line. Let these are two poles and let it is a bar magnet. And these are two poles. Let's we draw the figure again clearly. Now look at the figure. Let these are two poles of a bar magnet. Suppose it is a bar magnet. These are two poles. Let this pole is south pole and another is north pole, and it is a bar magnet. Let that two poles are separated by a small distance 2a. Let O be the center of a magnetic dipole. If O is the center of a dipole, so that the distance from center of dipole to south pole will be A, as well as the distance from center of dipole to north pole will be A. So now we have to take a point which is present neither axial line of the bar magnet and nor the equatorial line of the bar magnet. Let's it is the axial line. What is the axial line of the bar magnet? The axial line is different of the line which journey between two magnetic poles and passing through the center of a magnetic dipole. So that here let's point that line is AB. Let AB is the magnetic length or dipole length. Now we have to take here a point P. Let that P point having a distance of a small r from center of magnetic dipole. It means the P point is such a point which is present neither axial line nor equatorial line, and that P point is present at a distance small r from the center of magnetic dipole O. Now look at the figure here. Already you have known in the previous class that the magnetic dipole moment is always directed from south pole to north pole, so that it is the direction of magnetic dipole moment and its symbol will m vector. So here m is a vector which is called magnetic dipole moment and which is directed inside the bar magnet from south pole to north pole, so that it is called m vector. But all of you know in first year that a vector can be split up into two scalar components. One is called cos component and another is called sin component. So here OP, here P is a point, and if we take O is an origin, so that P is the position vector. P is a position vector with respect to O. So in this figure, that P point is present at distance small r. We have to take the small r is a position vector, so that r vector or r is the position vector, or it is also called r. R will be magnitude and r vector will be the position vector. Now let theta is the angle between the r vector and m vector. Now we can split up these vectors into two scalar components. Already you have known a vector can be split up into two scalar components. Let it is a vector, and if we split the vector into two components, the one component at which the vector made angle theta, that is called cos component. So here this line is called a cos theta, and the another line which is perpendicular to the a cos component is called sin component. So it will be a sin theta. That similarly concept will be applied here. So according to this concept, here OP is called R, and which is also called I think M cos theta. Similarly, another perpendicular vector it can be drawn. Let a perpendicular vector, the south pole, it is north pole, it is the direction, and this vector is taken as m sin theta because the component which is perpendicular to the cos component is called sin component. So here m cos theta and m sin theta are perpendicular with each other. It means the vector m splits up into two scalar components. One is called cos component, which is known as m cos theta, and the another component is m sin theta, and which is called vertical component. So these are the completely figure. And now P is the point. At P point we have to find the net magnetic field. Look at the figure. Here the P point is present on the axial line of m cos theta, so that it is the direction. It is the direction of m cos theta at point P, m cos theta. And another perpendicular line is called sin component, which is known as m sin theta, and that m sin theta is perpendicular to m cos theta, so that m sin theta is the magnetic dipole moment which is produced due to equatorial line of the bar magnet or dipole moment vector m vector. Here m cos theta and m sin theta are two components. If these are two components, or all of you know, according to parallelogram law, if two vectors act simultaneously at a point, then these two vectors are taken as the two sides of a parallelogram, and then their diagonals is known as the diagonal. Similarly, this concept is applied here. If m cos theta and m sin theta are two vectors, then it is the diagonal of these two vectors, and this diagonal is known as finally m, which is known as resultant. So now we have to find this m vector or m resultant, or it is also called m net vector. We have to find it. First of all, in this figure we have to apply both cases. One is called axial line concept, and another is called equatorial line concept. So the magnetic field. The magnetic field at P. The magnetic field at P due to m cos theta on axial line of P is, we have to take that axial line magnetic field is B1 vector, so that B1 vector I have already discussed in the previous class about the magnetic field on axial line due to dipole. And that formula is mu naught upon 4 pi into 2m upon r cube. But here 2m, here m vector splits up into two scalar components. One is called m cos theta, so here m becomes m cos theta. It will be 2m cos theta, and it is taken as equation 1, 2m cos theta. Now write down this notes from the blackboard, then I will remove it. Okay, now I will remove. Now I have already found B1. We have to find B2. So what will be that B2, that B1 is along the line P. Let's we have to take to x, y, z, and that B1 is taken along px vector. That B1 is taken along px vector. Again, so B2 vector. What will be B2 vector? That same formula is applied here, but here B2 means the magnetic field. B2 is the magnetic field B2 is the magnetic field. B2 is the magnetic field at P due to equatorial line. Due to equatorial line. So that what will be B2? B2 vector is equal to mu naught upon 4 pi along Px. It will be equation 1. It is the scalar quantity magnitude mu naught upon 4 pi. All of you know for equatorial line the magnetic field will be backward constant into dipole moment upon r square. So that mu naught upon 4 pi m. But now m will be m sin theta, so m sin theta upon r cube. It will be B2 vector. So that the B2 vector will be mu naught upon 4 pi into m sin theta upon r cube. It will be B2 and it will be B1. So now we will get equation 1 and equation 2. Now we have to find the net magnetic field. We have to find the net magnetic field. So we have to apply the formula of parallelogram law. Now remove the figure. I will remove it. Note down all these notes from the blackboard. I will remove. What you have already known, the magnetic field B net. What will be the formula? R vector magnitude. It is called resultant. Its formula will be square root of a square plus b square plus 2ab cos theta. And this formula is applied here. We have to apply this formula in this by equating b1 and b2. So it is the net magnetic field, and it is also called resultant magnetic field, and it will be b net, and its formula will be b net will be mu naught upon 4 pi into m a square. Now we have to take b1 is a square, so b net will be b1 square plus b2 square plus 2b1 into b2 cos theta is square root. Now I will remove these 2 points from the green board. You have to write down these 2 points. Next point, that will be b net. Then the b net vector will be b1. b1 means b1 plus b2 square to b1 into cos theta. So b1 will be mu naught upon 4 pi into mu naught upon 4 pi into 2m cos theta upon r cube its whole square plus b2 square. It means mu naught upon 4 pi m sin theta upon r cube its whole square. But 2b1 b2 cos theta, here theta is 90 degree here, because theta is the angle between m cos theta and m sin theta. So the angle between m cos theta and m sin theta is 90 degree. So the total term will be vanished, because this term will be 0, because cos 90 equal to 0. So that which image b net will be b net vector. Here in this concept, mu naught upon 4 pi is a constant. It will be removed outside of the equations. Mu naught upon 4 pi into 2m upon r cube. These terms will be remains as common into square root of cos square theta plus 4 2 cos theta 2 cos theta square. It will be 4 cos square theta plus sin square theta. 4 cos square theta plus sin square theta. It will be b net vector is equal to mu naught upon 4 pi into 2m upon r cube into square root of 4 cos square theta plus sin square theta. Cos square theta plus sin square theta is 1, and here 3 cos square theta, so it will be 1 plus 3 cos square theta. So it is the final formula. Now we'll get a V net vector due to dipole at any point. It will be mu naught upon 4 pi into 2m upon r cube into square root of 1 plus 3 cos square theta. It is the final formula. And if beta is the angle between B net and B1, then what will be tan beta? Then tan beta will be m sin theta B1, then tan beta will be B1 upon B2. So these are the final formulas. Thank you, students. Thanks for watching my videos. God bless you, students.